Now, before we go into the solution of this question, let me take a minute to explain how tricky this is, and at the same time how beautiful this is. Tricky because it would take some time to understand the difference between these three cases. Beautiful because conceptual it is. Now, you don't need to appreciate the beauty or the trickiness behind this question. You can just do this solution. It's really important to understand the concept and just don't, do a jugaad solution here. Make sure that you understand what you're doing. Make sure that the calculation that you're trying to do is something you are doing out of the clarity in it and not just for the sake of doing it. Okay? Right. To begin with, we will try to visualize what's given in the question. A boy reaches the airport and finds that the escalator is not working, which is represented in the first case here. The escalator is not working. He walks up the escalator in time t1. So this corresponds to time t1. This would be t2 and this would be t, say. If he remains stationary on a moving escalator, then the escalator takes him up in time t2. The time taken by him to walk up on the moving escalator. So, for the sake of our understanding, I have assumed the velocity of man to be 3 meters per second and velocity of escalator to be 1 meter per second, which actually is the usual velocity in most of the escalators, 1 to 1.5 meter per seconds. Okay, both horizontal and the inclined ones. Now, man is walking, escalator is stationary, which means velocity of man is equal to 3 meter per second and velocity of escalator is equal to 0. Likewise, velocity of man is 0 when he walks up when he remains stationary on moving escalator, but the escalator is moving and the velocity is 1 meter per second. Now, when the man is moving on a moving escalator, both of them have velocities corresponding to 3 meter per second for man and 1 meter per second for the escalator. Okay, why have I taken these values? Just for random values to make sure that we get the relative velocity concept clear. Now, by this time, if you have followed the solution so far, you should be in a state of mind to ask one question. What is that? These velocities mentioned here, what are they with respect to? Are they with respect to the man? Are they with respect to the escalator? Or are they with respect to the ground? Right? So, let us spend some time to understand the formula here. Velocity of man with respect to ground will be equal to velocity of man with respect to escalator plus velocity of escalator with respect to ground. Now, what is this? To understand this formula, we need to understand the basic formula we need to derive the basic formula for relative velocity. What is that? So, velocity of man with respect to escalator is equal to, velocity of man with respect to ground. Okay, let me just write down the other way. So, velocity of man with respect to escalator is equal to velocity of man with respect to ground minus velocity of escalator with respect to ground, something that we have discussed many times, right? So velocity of A with respect to B is equal to velocity of A minus velocity of B, and from the inertial frame this becomes velocity of A with respect to ground minus velocity of B with respect to ground. Similarly, velocity of man with respect to escalator would be equal to velocity of man minus velocity of escalator, but man with respect to ground and velocity of escalator with respect to ground. Does that make sense? Now, go through this a couple of times. Write down this. Explain this to yourself. Make sure you get the idea correct. Okay? Now, once you get the idea correct, the man's total velocity relative to the ground is the sum of his speed relative to the escalator and speed of the escalator relative to the ground. Might be confusing. I do understand that. Pause it, read it, write it down one more time, and explain this to yourself. We'll apply the written formula 3 times, and then things would make more sense to you. All right? Let's see what do we have here. Man walks at 3 meters per second on a stationary escalator. What do we have here? Which means, let us write on the formula. Let's bring it over here. Oops, my bad. Okay. Now, we have the formula here that velocity of man with respect to escalator is equal to velocity of man with respect to ground minus velocity of escalator with respect to ground. Now, let's plug in these values here. So, what is velocity of escalator with respect to ground? Velocity of escalator with respect to ground is 0 meter per second. Why? Because it is stationary here. So, this becomes minus 0. What is velocity of man with respect to ground? We don't know. So that stays velocity of man with respect to ground. Oh, my bad. I almost forgot to mention this. We are doing this with reference to the observer in ground, or in other words, the inertial frame. Which means every measurement we make regarding the motion, displacement, velocity, everything would be with respect to the ground. Okay. So yes, I had to should have said that before. Okay. Now, so we're talking about velocity of man with respect to ground. Now, what is velocity of man with respect to escalator? Velocity of man with respect to escalator is 3 meter per second. Is 3 meter per second. Therefore, what is velocity of man with respect to ground? Minus 0, transposes, that becomes plus 0. Therefore, velocity of man with respect to ground is 3 meter per second. What does this mean? This means that a person who is standing on the ground at rest, he will see, what he will visualize is that a person is climbing up the escalator at 3 meter per second. Okay. Now you might be wondering what's so conceptual in that. That will become more clear while we discuss the third case. Now let's go to case 2. So we need this expression here as well. So, which is the frame? The ground frame. Where is the person, the observer standing? The observer is standing on the ground. The observer is standing on the ground. So all the measurements which are made regarding the motion will be with respect to the ground. Now, velocity of man with respect to escalator. Velocity of man with respect to escalator is 0. Why? Because the person is standing stationary here. Now, what is velocity of man with respect to ground is what we are trying to find out. What is velocity of escalator with respect to ground? The escalator is moving at the speed of 1 meter per second, which means velocity of escalator with respect to ground here would be 1 meter per second. In which case, what is velocity of man with respect to ground? You transpose minus 1. What you get is velocity of man with respect to ground is 1 meter per second. What does this mean? This means that a person at ground would see, if he observes this man, he will visualize that the velocity of this man is going up the climb is climbing up the stairs at a speed of 1 meter per second. What was it earlier? In the previous case, it was that the observer in ground is observing the man, visualizing the man that he's going up with a speed of 3 meter per second. In the second case, that becomes 1 meter per second. Okay. If you can make the third case on your own, it means that you are paying much attention and that you're writing and explaining things to yourself, which will help you a lot in the exam. Now, when it comes to case 3, when the man is walking on a moving escalator, so both of them are in motion, the man, the escalator as well. Now, velocity of man with respect to escalator is man with respect to escalator. This case is 3 meter per second. We have to find velocity of man with respect to ground, and velocity of escalator with respect to ground is 1 meter per second. Transposing minus 1, what we get is 3 plus 1 is equal to velocity of man with respect to ground. What does it mean? It means that an observer at ground who considers this motion would see, or would apparently see, that this man who is walking at 3 meter per second on an escalator moving at 1 meter per second is apparently seen to be moving with a speed of 4 meter per second. So velocity of man with respect to ground is 4. So what is the actual velocity of this man going up? It is 3. But how does what velocity will this man on the ground will see this? At 4. That's the beauty. That is the concept here. I hope now you understand why is it tricky and why is it conceptual. Okay. Now let's just summarize this. If you have not taken notes so far, most of us wouldn't have. I have a very humble request. Please make a note of this one at least. Would help you a lot while you revisit this question, or maybe while you revisit this question during your revision, or maybe one day, prior to your exam, you might need this handy. So, written things in detail here. Case 1, when the man is walking on a stationary escalator, velocity of man with respect to ground is 3 meter per second. Now, this column is where a potential question in the future would come based on statements or maybe assertion reasoning. So, man is stationary. Now, everything that I see here is with respect to ground here. So, a person, an observer standing on ground would see a man at 3 meter per second, would see the same man at 1 meter per second if he's standing on a moving escalator. But this observer standing on the ground would see the same man who is walking on an escalator, which is moving at 1 meter per second, where the man is moving at 3 meter per second in a combined speed of 4 meter per second. Now see, I have to admit, this is not what the question is actually about. Yes, I truly admit that. I've taken a lot of time on this explanation as well. But see, the reason why we are practicing PYQs is not just to solve them, but is to understand the concept, is to extract the concept out of them, and to make sure that we are so covered with all the topics within that question, that a question, if asked in the future from the same question, you should be able to answer it. Don't expect the same question, expect similar ones. Each and every option in a previous year question could be a potential. In fact, it is a potential upcoming question. Okay. Now coming into the actual question. So in this case, Velocity of case 1, velocity of escalator with respect to ground is 0. Why is it 0? Because the the escalator is stationary. Case 2, the man is stationary, therefore velocity of man with respect to escalator is 0, right? Is there a mistake here? Okay, right. No, things are fine. Okay. So this would become 0. But in the third case, none of them is 0. And velocity of man with respect to ground is actually the sum of velocity of man with respect to escalator and velocity of escalator with respect to ground. Now we have the corresponding times, which are Vmg at T1, Vmg at T2, and Vmg at T, corresponding to case 1, case 2, and case 3. So in all three cases, the distance traveled remains the same. The distance traveled remains the same. The distance traveled remains the same. Why? Because the distance traveled is actually the length of escalator. Okay. So velocity in all three cases is actually displacement by the corresponding time. Corresponding time in the first case is T1, second case is T2, and in the third case is T. Okay. Now, from these three expressions, we can say that L by T1 is Vme, L by T2 is Veg, and the only left over here is L by T is equal to Vme plus Veg. But what is Vme? So we can plug in Vme here. What is Veg? Which can be plugged in from here. So what we get is Vme L by T1, Veg L by T2 into this equation. L by T is equal to L by T1 plus L by T2. Dividing this complete equation by L. 1 by T is equal to 1 by T1 plus 1 by T2. And therefore 1 by T is equal to T2 plus T1 by T1 T2, or taking the reciprocals, T is equal to T1 T2 upon T1 plus T2, which gives us the correct option as T1 T2 upon T2 plus T1, which is option C. Okay, now I will leave this for you to write down. Okay, make sure that you understand the concept really well. Take a minute to pause the solution, take a minute to pause yourself. Don't be in a rush, don't be in a hurry to solve the question. Rather, make sure that you get satisfaction by understanding the concept in it and then solving it quickly. Okay, see, the speed of solution, as I've said it many times in my in the previous solutions, make sure that you don't focus on the speed by doing calculations in a rush. You should focus on your grasp on the concepts, and then when you apply it many times, speed comes naturally to you. Okay.